Hi guys, this is the Java series. In this session we will discuss about how the super keyword is used to invoke the immediate parent class constructor. Okay, we have already discussed about constructor. Mainly constructors are used to initialize the variables or objects. We have two types of constructors. One is the default constructor and the second one is the parameterized constructor. Here, how to call the immediate parent class constructor using the super keyword. Okay, so in this example, I have created two classes, animal super 2 and dog super 2, and one more class, test super 3. Okay, so this is my parent class and this is my child class. Okay, here inside my parent class, I have the default constructor. So what is it? This is the default constructor because it does not contain any parameters. That's why we can call it as this is the default constructor. The name should be same as the class name. Okay, there is no return type. Okay, so this is called the default constructor. Okay, so when this constructor will be invoked? During the creation of the object of the class only, this constructor will be automatically invoked. We already discussed about these things. Okay, here what is the role of this constructor? This constructor is used to print animal on my console. That's it. Simple task. Okay, and here I have implemented the single inheritance concept. We know this is the syntax for single inheritance. This is the child class name, extends keyword, and this is the parent class. That means this child class inherits all the properties and behaviors from this parent class. Inside this child class, I have a constructor. Okay, the constructor name should be same as the class name. Here also the default constructor because it does not contain any parameters. Okay, and there is no return type. Inside this constructor, I have the super keyword. Okay, so what is the role of this super? Here this super is used to invoke the constructor which is present inside the parent class of this child. That means this will be invoked. Okay, so this super keyword is used to invoke the immediate parent class constructor. And here we have one more statement. The statement is used to print the dog on my console. Okay, and here I have created one more class, test super 3. Inside this class only I have the main method. So my file name should be same as this class name only. Okay, execution starts only from the main method only. Okay, here I have created the object. D is my object for this subclass or child class. New keyword is used to create the memory for this object during the execution of the program. And this is the default constructor. Okay, we know already. Okay, the constructor will be invoked during the creation of the object of the class, isn't it? So, what happens after encounter this line? The control jumps from the 20th line to the subclass constructor. But inside this subclass constructor, we have the superclass constructor, isn't it? If I use super keyword inside the constructor means it refers to the immediate parent class constructor. So what will happen? The control again jumps from the 12th line to the parent class constructor. Okay, here I have the statement animal. So this statement will be executed. After then the control again jumps from the 6th line to the 13th line. Here we have the statement dog that will be printed on our console. And again the control jumps from the 13th line to the 21. So let me execute this one. So this is our output, animal and dog. Okay. So during the creation of this object, what will happen? This child class object will be invoked. So the control jumps from the 20th line to the 10th line. But inside this child class constructor, we have super keyword. So this super keyword is used to invoke immediate parent class constructor. So the control again jumps from the 12th line to the 3rd line. That is the constructor which is inside the parent class. So this statement is executed. That's why we got animal. And then again the control jumps from the 5th line to the 13th line. Here we have dog. Okay, this is from the child class constructor. That's why we got dog. Again the control jumps from the 13th line to 21. That's it. In this example, we have used the super keyword. This super keyword is used to invoke the immediate parent class constructor. I hope you all understood about the super keyword that is used to invoke the immediate parent class constructor. Okay. Here I have explicitly write super keyword. In this example, I didn't use any super keyword to invoke the immediate parent class constructor. Still, the immediate parent class constructor will be invoked. How? With the help of the compiler, the immediate parent class constructor will be invoked implicitly. Okay, let me execute this one. Here I have animal and dog. But in this example, I didn't use any super keyword to invoke the immediate parent class constructor, isn't it? Still, this immediate parent class constructor is invoked. How? With the help of the compiler. Okay, that is happened implicitly. That's why we got animal here. Got it? What is the difference between the previous and this current example means all the lines are the same. Okay, but here I didn't use the super keyword. Inside the child class constructor, I didn't use any super keyword, but here I have used the super keyword explicitly. In this case, I didn't use the super keyword, but that super keyword is automatically generated by the compiler implicitly. That's why we got animal here. Okay, so here I have created the object of the subclass. Here this is the child class constructor. So the control jumps from the 20th line to the 10th line. This is the constructor which is inside this subclass. Inside this subclass constructor, I didn't have any super keyword. Still, the control jumps from the 12th line to the immediate parent class constructor with the help of the compiler. Okay, that's why we got this animal in our console like this. And then the same like the previous example, the dog is printed. Got it? So the super keyword is used to invoke the immediate parent class constructor explicitly or implicitly. In this session, we will discuss about how the super keyword is used for reusing the parent constructor. Okay, so here this is the example program. I have created person and EMP. Here person is the parent class and EMP is the child class. I have implemented the single inheritance type. EMP inherits all the properties and behaviors from the person. Okay, inside this person I have created two variables, ID and name. What is it? This is the parameterized constructor. Okay, the name of the constructor should be same as the class name. And here we have the parameters. That's why we can call it as parameterized constructor. Okay, so what is the task of this constructor? This constructor is used to initialize the variables which are present inside the person class. Okay. Here I have used this keyword. So we already discussed about this keyword. So this keyword is used to refer the current class object. Okay, so this dot id means the id is present inside this person class. Okay, what is it? This id is the parameter. Okay, here the name is the parameter, but here the name is what? This is refers to the current class variable. And here I have created the EMP. EMP inherits all the properties and behaviors from the person class. Single type inheritance I have implemented. I have created one variable inside the subclass. Its data type is double. Okay, and here this is again the constructor. Okay, the constructor name should be same as the class name. And here we have 3 arguments or parameters. That's why it's called the parameterized constructor. Okay, and inside this subclass constructor I have used the super keyword. Okay, so here I have 2 values, id and name, and here this dot salary. This id and name will be initialized with the help of the immediate parent class constructor. Okay, so what is the immediate parent of this EMP? Person. So after encounter this line, the control jumps from the 16th line to the 5th line, and here the id and name will be initialized. Again the control jumps from the 8th line to the 17th line. Then only the salary will be initialized. This salary is from EMP. This id and name values from the immediate parent class. Okay, that's why we can use the super keyword here. And I have created the method display. This is the return type void. So here the values of id, name and salary will be printed on our console. Okay, and here I have created one more class, test super 5. Inside this class only I have the main method. So my file name must be same as this class name only, and execution starts only from the main method. Here I have created the object for the subclass, that is EMP. New keyword is used to create the memory for this object during the execution of the program. And here, what is it? This is the parameterized constructor. Okay, so what happens after encounter this line? The control carries these values 101, Anita and 45,000 and jumps from the 28th line to the 14th line. Here the 101 will be stored inside the id and Anita will be stored inside the name and 45,000 will be stored inside the salary. And the control comes inside this subclass constructor, and here we have the super keyword with id and name arguments. After encounter this line, what will happen? The control carries the id value and name value and jumps from the 16th line to the 5th line. Because here we have the super keyword. Super is used to refer the immediate parent class constructor only, isn't it? Here. So the control comes here. So id value is 101 and name value is Anita, isn't it? So those values will be initialized to id and name. Okay, so this id and name which are belongs to the person class. After then the control again jumps from the 8th line to the 17th line. Okay, and here we have the salary field. That salary will be initialized. Got it? Again the control jumps from the 17th line to 29th line. Here we have the object E1, that is the subclass object dot display. After encounter this line, the control jumps from the 29th line to the 19th line. Here we have the println statement and the ID will be printed, that is 101 will be printed, name will be printed, that is Anita will be printed, and salary, that is 45,000 will be printed on our console. Okay, let me execute this one. Here 101, Anita 45,000. What is happened here? This is the parameterized constructor. So these parameters is carried by the control and jumps from the 28th line to the 14th line. And here we have the super keyword with arguments ID and name. The values of ID and name is carried from the 16th line to the immediate parent class constructor, because super refers to the immediate parent class constructor only. So the control jumps from the 16th to 5th line. Here the values ID and name is initialized. Okay, after then the control jumps again from the 8th line to the 17th line, and here salary is initialized, and then the control jumps from the 17th line to the 29th line. Here event.display. So the control jumps from the 29th line to the 19th. Here all the values is printed like this. Got it? So in this example we have used the super keyword. Okay, this super is used for reusing the parent constructor. I hope you all understood about how the super keyword is used for reusing the parent constructor. In this session, we will discuss about constructor chaining. What is constructor chaining? Constructor chaining is the process of calling one constructor from another constructor with respect to the current object. I repeat it again. Constructor chaining is the process of calling one constructor from another constructor with respect to the current object. What is the usage of constructor chaining? It makes the program more readable. This is the advantage of constructor chaining. How can we do constructor chaining? There are two ways. The first one within the same class by using the this keyword. The second one from base class by using the super keyword. In this session we will discuss about how constructor chaining can be done using this keyword, that is within the same class. Okay, here I have created the package constructor chain. Okay, this is the name of the package. Inside this package I have created the class. The class name is chain this. Okay, and here what is it? This is the default constructor. The name should be same as the class name. Okay, and here there is no parameters. That's why this constructor is the default constructor. Okay, inside this constructor I have created the another constructor. Okay, so this is called the constructor. This keyword is used to refer the current class object. So this of 5. Here I have passed the parameter value. Okay, this is the default constructor. Inside this constructor I have the constructor, but this is the parameterized constructor because here I have given the parameter value. Okay, and I have created one more constructor, but here I have given the parameter. Okay, x is the argument, its data type is integer. Okay, the name should be same as the class name. Okay, and inside this parameterized constructor I have the another constructor. Okay, here I have two parameters. Inside the single parameter constructor I have the two parameters constructor. this keyword refers the current class object. Okay, so this statement is the parameterized constructor. This parameterized constructor is placed inside the single parameterized constructor. And one more statement. This statement is used to print the value of x on my console. Okay, and here I have created the third constructor. Here I have given two arguments, x and y. Both are integer data type. Okay, and here I want to print the multiplication of x and y on my console. Okay, and inside this class only I have the main method. So my file name should be same as this class name only. Okay, change this .java file. Okay, so here the default constructor. Here there is no parameter. Okay, so what happens? Actually, execution starts only from the main method. Already we know. Okay, so here we have the default constructor. There is no parameter. So the control search where this constructor that contains no parameter. Where is it? Here only that constructor is present. So the control comes here, and inside this default constructor I have the parameter, that is the single parameter constructor. So the control again jumps from the 12th line to the single parameter constructor. Here the control comes. And inside this single parameter constructor, I have the two values constructor. Okay, so the control again jumps from the 20th line to the double parameter constructor. So the control comes here, and here what we have, multiplication of x and y. So our result will be the multiplication of 5 and 15, because this 5 will be stored inside the x and 15 will be stored inside the y. So 5 into 15 will be the result. Okay, and again what will happen, the control after printing this statement jumps from the 28th to the 21. The x value alone will be printed, that is 5 will be printed on our console, and then the control jumps from the 21 to the 12th line. Okay, and here the default constructor will be printed on our console. Okay, and then the control jumps from the 13th line to the 34. So the program will be finished. Is it clear? So this process is called the constructor chaining. So constructor chaining is the process of calling one constructor from another constructor with respect to the current object. Okay, let me execute this one. Here, this is my output. The execution starts only from the main. Here I have the default constructor. Inside the round brackets there is no parameter. So the control jumps from the 33 to the default constructor, 9th statement, and here we have the single parameter constructor. So the control search where the single parameter constructor. After finding the single parameter constructor, the control jumps from the 12th line to the single parameter constructor. Here this 5 is stored inside the x variable, and then the control comes inside the single parameterized constructor, and the double parameterized constructor is placed. After finding the two argument constructor, the control again jumps from the 20th line to the double parameterized constructor. Here the 5 is stored inside the x and 15 is stored inside the y, and this value, that is the multiplication of 5 into 15, is printed. After that, the control again jumps from the 27th line to the 21st line, and the value of x is printed. That's why we got 5 here. And then the control again jumps from the 21st to the 13th line. That's why we got the default constructor here. Okay, so this process is called the constructor chaining. In the last session, we have discussed about constructor chaining. What is constructor chaining? Constructor chaining is the process of calling one constructor from another constructor with respect to the current object, isn't it? And constructor chaining can be done using this keyword and super keyword. Okay, we have only discussed about how the constructor chaining can be done using this keyword. And constructor chaining can be done in any order. It may be a descending order of the arguments, or it may be the ascending order of the arguments. Okay. In the previous session, we have discussed about how the constructor chaining can be done in the descending order. Okay. In this session, we will discuss about how the constructor chaining can be done using this keyword in ascending order. Okay. So here I have created the package. This is my package name and this is my class name. Inside this class only I have the main method. So I have given the file name as this class name only, and inside this class I have created the constructors. The constructor name should be same as the class name. Already we have discussed. Okay. And there is no return type. Okay, and what type of constructor is this? This is the default constructor because it does not contain any arguments here. Okay, and what is the role of this constructor? It's used to print the default constructor on my console. Okay, and here I have created one more constructor, but it contains the single parameter, that is single argument. Its data type is integer. What is the role of this single argument constructor is, it is used to invoke the current class default constructor because this keyword is used to refer the current class object. Already we discussed about this keyword. So what is it? This is used to refer the current class default constructor because inside the round brackets there is no arguments. This statement is used to invoke the default constructor of this class. Okay, and here we have one more statement. The value of x will be printed on my console. And here I have one more constructor. Inside this constructor I have used two arguments. And what is the role of this double parameterized constructor? Here this of 5, that is single parameterized constructor. So here this keyword is used to invoke the single parameterized constructor of this class. Okay, so here I have the value 5. That value 5 will be stored inside the x variable, and all the statements inside the single parameterized constructor will be invoked. And here we have one more statement. So this statement is used to print this on my console. Multiplication of x and y value will be printed on my console. Okay, and here I have the main method. So execution starts only from the main method. So after encounter this line, what will happen? The control jumps from the 32nd line to the double parameterized constructor. Where is it? Here we have. So the control comes here and the 8 will be stored inside the x variable and 10 will be stored inside the y variable. Okay, and all the statements inside this double parameterized constructor will be executed. So let me execute this one, then only you can understand easily. So this is our output. So execution starts only from the main method. Here after encounter this line, the control carries the 8 and 10 and jumps from the 32nd line to the 22nd line because here we have the constructor with two argument values. So the control jumps from the 32nd to 22nd line. Here 8 is stored inside the x and 10 is stored inside y, and inside this double parameterized constructor we have the single parameterized constructor because this keyword refers the current class object, and here we have the single parameter value. So the control again jumps from the 25th line to the single parameterized constructor, that is here the control comes and the value 5, that is here we have the 5. So that value is stored inside the X variable, and inside this single parameterized constructor we have the default constructor. This refers the current class object. Here there is no parameter values, and the control jumps from the 17th line to constructor. Here we have the statement default constructor. That's why we got this output here. After then, the control again jumps from the 11th line to the 18th line. Okay, so here we have this statement. So the X value is printed here. That's why we got this statement here. And then the control again jumps back to 26th line. Here we have the statement multiplication of X and Y. That's why we got this value. That is 8 into 10, 80 is the result. Okay, after then the control jumps from the 26 to 33. The program is finished. Okay, so what order is this? This is the ascending order. Here this is the default constructor, means no parameters. Here single parameter and then 2 parameter. So this order is the ascending order. But in the previous session we have seen this example. Now I execute this. Here 2 parameters and single parameter and then no parameter. So this is the descending order. So constructor chaining can be done in any order. Okay, any order means what? Ascending or descending order. So in this example we got the descending order output. Here in this example we got the ascending ordered output. I hope you all understood about what is the constructor chaining, and constructor chaining can be done in any order, that is either descending or ascending order. Okay. Hi guys, this is the Java series part 43. In the last session we have discussed about how the constructor chaining can be done using this keyword. In this session we will discuss about how the constructor chaining can be done using the super keyword. Here I have created the package. Inside this package I have created the base class. Inside this base class I have created the name variable. Its data type is string. And inside this base class I have 2 constructors. This constructor is the default constructor and this constructor is the parameterized constructor. The constructor name should be same as the class name. Here there is no argument. That's why we can call it as the default constructor. Here we have the argument. That's why we can call it as the parameterized constructor. And I have created one more class. This class name is derived and it inherits the base class. Okay. So what type is this? Single inheritance type. Derived class inherits all the properties and behaviors from the base class. Inside this derived class also we have 2 constructors like the previous, default and the parameterized. Okay, and here I have created the chain super class. Inside this class only I have the main method. Execution starts only from the main. Inside this class only I have the main. So my file name should be same as this class name only. And here I have created the object for derived class, object 1 and object 2. Okay, here I have used the default constructor for object 1 and here I have used the parameterized constructor for object 2. Okay, after encounter this line, the control jumps from the 46th line to the 25th line, because here only the default constructor. Inside the round brackets there is no arguments. That's why the control jumps from the 46th line to the 25th line. And inside this default subclass constructor I have the super keyword. Okay, so super refers to the immediate base class constructor, because this is placed inside the constructor. So this super is responsible to invoke the super class constructor only. So the control again jumps from the 27th line to the 8th line, because this is the default constructor for this base class. That's why the control comes here. And inside this default constructor, I have this keyword. Okay, this of family means this is the argument value. This refers the current class object. So it indicates the single parameterized constructor. So the control jumps from the 10th line to the 15th line. Here we have the parameterized constructor. So this is used to invoke the current class parameterized constructor. Got it? And inside this parameterized constructor, again we have this keyword. Using this keyword, I initialize the variable which is present inside the base class. So this refers the current class object. This dot name is equal to name. This name is the constructor argument, and this name is the variable which is present inside the base class. Okay, and here we have one statement. So this will be printed on our console with the value of the name variable which is present inside the base class. Next, what will happen? The control jumps from the 18th line to the 11th line, and this statement will be printed on our console. And then the control jumps back to the 28th line. Okay, so we will get this statement on my console. Okay, and again the control jumps back to the 48th line. Here I have one more object for the same subclass or derived class. Okay, and here I have used the parameterized constructor. Okay, so the control carries the value happy and search where the parameterized constructor of this derived class. After finding the parameterized constructor for this subclass, the control jumps from the 48th line to the 32nd line, because this only the parameterized constructor. Okay, and this happy will be stored inside the name variable. And here we have the super keyword. This super keyword is used to refer the immediate parent class constructor only, because this is placed inside the constructor. So this statement is used to invoke the super class constructor. What type of constructor? Parameterized constructor, because here we have the parameter value. Okay, so the control jumps from the 35th line to the 15th line here, and that happy will be stored inside the name variable, and that value will be stored inside the this dot name. That is, happy will be stored inside the name variable which is belongs to this base class, and then this statement will be printed on our console. And then the control jumps back to here. So this statement will be printed on our console. The name happy will be printed on our console. Let me execute this one. So execution starts only from the main method. Okay, object 1 is the object of the derived class. Here we have the default constructor. So 46 to the default constructor of a subclass here. And then the control jumps from the 27th line to the default constructor of the superclass. So control comes here, and here this of family. So the control jumps from 10th line to the base class parameterized constructor. So that value is printed here, family. Okay, and then the control jumps back to the 11th line. Here we have this statement. That's why we got this one on our console. After then the control again jumps back to the 28th line. Here we have no argument constructor of derived class. That's why we got this output. Okay, again the control jumps back to the 48th line. Here the object name is object2. Here we have the parameterized constructor. Okay, so the control jumps from the 48th line to the 32. Happy is stored here and super of happy. So the immediate parent class parameterized constructor. So the control comes here and happy is stored inside the name. That value is stored inside the name which is inside the base class. That's why we got this output. After then the control again jumps back to this statement. 36th line. So this is printed here. Name is happy. Okay. So this is the execution flow of the constructor chaining using the super keyword. Okay. I hope you all understood about how the constructor chaining can be done using the super keyword. In this session, we will discuss about the final keyword. What is the role of the final keyword? It is used to restrict the user. Final keyword can be used in many contexts like variable, method, class, argument in functions. Okay, in this session, we will discuss about final variable and final method. Okay, so this is the example program for how the final keyword can be used as variable and what is the role of the final variable. Okay, inside this byte9 class, I have created the speed limit. This is the name of the variable. Its data type is integer. Here I have written final keyword and I have initialized 90 is the value for speed limit variable. Okay, and inside the byte9 class, I have created the method run. Method name is run. Return type is void. So what is the role of this run method? It is used to print the speed limit value on my console. Okay, but this is what? The final variable. Okay, so what will happen? It holds only the 90. If I try to give some different values to the speed limit means I will get error. So this is the role of the final keyword. If we make any variable as final means we won't change the value of that final variable. Okay, if I try to change the value of the final variable, we will get the error only. And this is the main method. Inside this method, I have created the object for byte9 class. Okay, my file name should be same as this class name because this class only have the main method. In this example, we have a single class only. And new keyword is used to create the memory for this object at runtime. And this is the default constructor. Here I have used this object to call the method run. Okay, so the control jumps from the 13th line to the 9th line. Here we have the speed limit. That value will be printed on our console. That is 90 will be printed on my console. Okay, let me execute this one. So this is my output. Okay, now I uncomment this line. What we'll get? We got the compile time error. What is it? The final field byte9.speed limit cannot be assigned. Why? Because here we have the final keyword. That's why we got this compile time error. Got it? If I want to remove this error means what I will do? I just remove this final keyword. Then the error will be gone. Let me execute again. Here we have 400. Because inside this run method I have initialized. Because the speed limit is now not a final variable. That's why I can reinitialize the variable. Okay. But if I give the final keyword here means I got again the error. So this is our error. Unresolved compilation problem. Okay. The final field cannot be assigned. Okay. So this is like a constant value. Okay. It will be constant only. If I try to reinitialize the final variable, I got this type of compile time error. I hope you all understood about what is the role of the final variable. So now I comment this line. Now I got the output 90. Okay. Now the next one, what is the role of the final method? Here I have created two classes, bike and Honda. Here I have implemented the single inheritance type. Inside this bike I have the method run. Okay, so what is the role of this run method? It is used to print running on my console. Okay, and inside the Honda we have the run method. We already discussed about the runtime polymorphism, that is method overriding. Okay, so the child class method run overrides the parent class method. Okay, this method overrides the parent class method. That is the method overriding concept. Okay, one of the pillars of OOPS concept. Okay, but if I make the method as final, means this overriding is not possible. Okay, if you don't like to override your parent class method, means you can use this final to your method. Got it? Let me execute this one. Here running safely with 100 kilometers per hour. Okay, so this method only is invoked. That's why we got this output. That means this run overrides the parent class run method. Okay, but if I make the method as final, means what will happen? Now I uncomment these lines and I comment this one. Here what is the difference? The previous execution I didn't use the final for this method, but now I have used the final to this run method. Okay, what will happen? Here we got the compile time error, multiple markers at this line. Let me execute. Here linkage error occurred while loading main class Honda. Java.language incompatible class change error. Class Honda overrides final method. That's why we got this compile time error. Multiple markers at this line, because here I have given the final keyword. So if I try to use the same run method inside the child class, means I got this type of error. Okay, so if we won't need the overridden concept, means we can use the final keyword to that method. Okay, if you provide this keyword, means we won't be overridden the parent class method. Okay, so now again I uncomment this line and comment this line. So now the error is gone. So if I make the run method as final, means this run method won't be overridden by the child class method. Okay, I hope you all understood about the final variable and the final method. If you make any variable as final, means we won't change the value of the variable. If you make any method as final method, means we cannot override that method. In this session, we will discuss about the final class and final parameter. Let's see this example. Here I have created the class, bike class. Inside this class, I have created the method. And what is the role of this disp method? It is used to print the display on my console. And I have created one more class, Honda 2. Here I have implemented the single inheritance type. Inside the Honda 2, I have the run method. What is the role of this method? It is used to print running safely with 100 km per hour on my console. And inside the Honda 2, we have the main method. We know the main method is the starting point of the execution of the program. And inside the Honda 2 only, we have the main method. So my file name should be same as this class name only. Okay, my file name is Honda 2 only. And Here I have created the object for Honda 2, that is the child class. And a new keyword is used to create the memory for this object at runtime. And this is the default constructor. Okay, using this object I call the run as well as the disp method. Okay, so here I have implemented the single inheritance type. So with the help of the object of Honda 2, I can access run as well as the disp method. Let me execute this one. This statement is the output for the 17th one, Honda.run. So the control jumps from the 17th line to the 10th line, that is the run method. Okay, so here we got running safely with 100 km per hour. And the control again jumps from the 13th line to the 18th line. Here we have the disp method. Okay, so this method is from the parent class bike class. Okay, so the control jumps from the 18th line to the parent class method disp here. And this is printed here. Now, if I use the final keyword with the class, means what will happen? Okay, now if I use final here, means we got the compile time error. The type Honda 2 cannot subclass the final class bike class. Okay, if we make any class as final, means we cannot extend that class. Okay, so we got the compile time error. The type Honda 2 cannot subclass the final class bike class. Okay, so if we don't want to inherit any class, means we can use this final keyword like this. I hope you are understood about what is the final class. If we make any class as final, we cannot extend it. Okay, and I have one more example. Here test final 1 is my class name. And inside this class, I have the speed limit. This is the name of the variable. Its data type is integer and I have used the final keyword here. We already discussed, if we make any variable as final, means we cannot change the value of the variable, isn't it? But here I didn't give any value to this speed limit. That is, I am not initialized here during the declaration of this statement. So what will happen if I try to give the value to this speed limit, means I will get error only. Then what is the solution? Inside the constructor only I can initialize the final variable. Okay, so this statement is called the blank final variable. That is, if we didn't initialize the value of the final variable, means that is called the blank final variable. It is also known as uninitialized variables. Okay, so this type of uninitialized variable can be initialized inside the constructor only. If we try to initialize this type of final variable outside of the constructor, means we will get error only. Okay, so if we want to initialize the speed limit during the creation of the variable, means I can. If I try to give the values after the declaration of the statement, means I get the error. So in those situations, we need a constructor to initialize that type of final variable. Got it? So here this is called the default constructor. The name of the constructor should be same as the name of the class. Okay, and here there is no parameters. That's why we can call it as the default constructor. Inside this default constructor only I can initialize this final variable. Okay, so here I have initialized the speed limit. The value is 70. And I print the value on my console with the help of the println method. And main method, execution starts only from this main method. We already discussed. And here I have created the object for the test final 1. That is the name of the class. And T1 is the name of the object. New keyword is used to create the memory for this object during the execution of the program, and this is the default constructor. Okay, this default constructor will be invoked during the creation of the object. We know already. Okay, let me execute this one. I got value is 70. So this uninitialized or blank final variable can be initialized inside the constructor only. Got it? And then final parameter. So this is my class name testFinal2. Inside this testFinal2 I have the method cube. Inside this function definition part I have the argument or parameter. N is the name of the variable, its data type is integer, and I have written the final keyword here. So this is the final parameter. If I make any parameter as final means we cannot change the value of this final parameter. Okay, here I have created the m variable and n plus 2. So the value of n and 2 will be added, and the added value will be stored inside the m variable. That value will be printed on our console. Okay, inside this testFinal2 I have the main method. So my file name must be same as this class name only, and execution starts only from the main method. I have created the object for this class, and this is the default constructor, and using this object I call the cube method. Okay, and this is my parameter value. So the control carries this 5 and jumps from the 12th line to the 3rd line, and the 5 will be stored inside the n variable. So let me execute this one. Here 5 plus 2 7. I got the result. Okay, if I try to change the value of this final parameter, is it possible? No. If I try to change the final variable value means we will get error only. I comment this line and I uncomment this one, and here instead of m I write n. Okay, here I try to change the final parameter n value. Okay, so I got the compare error. What error is this? The final local variable n cannot be assigned. It must be blank or not using a compound assignment. Okay, so if we make any parameter as final means we cannot change the value of the final variable. And again I comment this line and uncomment this one. I write m instead of n. Now the result is 7. 5 plus 2, 7. Okay, so we have completed the final class and what is blank or uninitialized final variable and what is the final parameter. In this session we will discuss about abstraction in Java language. What is abstraction? Abstraction is the process of hiding the implementation details and showing only the functionality to the user. Okay, in Java there are two ways to achieve the abstraction. The first one is the abstract class and the second one is the interface. In this session, let's discuss about the abstract class. What is abstract class? A class which is declared as abstract is known as abstract class. Abstract class can have constructors, abstract methods and non-abstract methods. Okay, what is abstract methods? A method which is declared as abstract is known as abstract method that does not have any implementation details. Okay, non-abstract method means the normal method that have the implementation details. Okay, see this example. Here I have created the bank. This is the name of the class and here I have written the abstract keyword. Okay, inside this abstract class I have created the method getRateOfInterest. Its return type is integer and I have written abstract. So this is the abstract method. This abstract class contains the abstract method. Now only we have discussed what is abstract method. Abstract method is a method that does not have any implementation details. Okay, and I have created the SBI class. Here I have implemented the single inheritance type. SBI inherits all the properties and behaviors from the parent class bank. In between the child class and parent class, I have used the extends keyword. Okay, and inside the SBI, I have the get rate of interest. This is the method which is from the bank parent class. Here we have only the declaration part, but inside the SBI, that is the child class only, we have the implementation details. Okay, so get rate of interest. This is the abstract method which is inside the bank parent class. Okay, inside the SBI, that is the child class only, I have the implementation details. Okay, so this method return 7. Okay, and I have created PNB class. SBI and PNB are the children and the bank is the parent. So what type is this? This is the hierarchical inheritance type. Okay, and inside the PNB I have the get rate of interest method. This is the abstract method from this bank, that is the parent class. Here we have the implementation details. Here I have written 8. Okay, and I have created the test abstraction 3 class. Inside this class only I have the main method. So my file name must be same as this class name only. So my file name is test abstraction 3. Okay, and here I have created the object for child 1 class SBI, and this is the default constructor. New keyword is used to create the memory for this object at runtime, and here using this object I call the get rate of interest method. So this method is from this SBI, so it returns 7. Okay, and here I have created one more object for the second child. Okay, and I call the get rate of interest using this child to object. So this statement returns the value 8. Got it? In this example, we have used the abstract class and abstract method. I hope you all understood about what is abstract class and what is abstract method. Okay, let me execute this one. So here b.get rate of interest. B is the object for SBI. So this value 7 I got. And here this get rate of interest for the child 2 P and B. So we got 8 here. Okay. So what is abstract class? A class which is declared as abstract is known as abstract class. Abstract class can have constructor, abstract method and non-abstract method. Okay, in this example we have only abstract method. Okay, I have one more example. In this example, I have created the bike ABS. Inside this bike ABS, I have created the constructor. Okay, the constructor name should be same as the class name. This class is the abstract class, not a normal class. Okay, inside this abstract class, I have the constructor and I have the abstract method and I have non-abstract method also. So what is the role of the constructor? It is used to print the bike is created on my console. This is the abstract method. We know abstract method, that is, does not have any implementation details, and this is the non-abstract method that have the implementation details. Okay, so what is the role of this one? It is used to print gear changed on my console. Okay, so inside this abstract class, I have constructor, abstract method and non-abstract method. Okay, and here I have created the class Honda and extends bike ABS. What type is this? This is the single inheritance type. Honda inherits all the properties and behaviors from bike ABS. Okay, and inside the bike ABS we have the abstract method, that is it does not have any implementation details. So this is from the bike ABS abstract method, and here I have given the implementation details. Okay, so what is the role of the run? It is used to printing running safely on my console. Okay, and I have created the test abstraction 4 class. Inside this class only I have the main method, so my file name should be same as this class name only. Okay, and here I have created the object for Honda, that is the child class. Okay, and this is the default constructor. Here using this object I call the run method. This is from the Honda. Actually this run is present in both Honda and bike ABS, that is child as well as the parent class, but inside the parent class we have only the abstract method. Inside the Honda only we have the implementation details. Okay, and what will happen, the control jumps from the 29th line to the 17th line. So this statement will be printed on our console, and then the control again jumps from the 20th line to the 30th line. Here we have the change gear method. Okay, so I have used the same object, and the control jumps from the 30th line to the 8th line. This statement will be printed on our console. Let me execute. Here, first during the creation of this object, the default constructor is invoked. So the control jumps from the 28th line to the 3rd line, because this is the default constructor, isn't it? So this constructor is invoked, that's why we got bike is created here. Okay, and after then the control again jumps from the 6th line to the 29th line. Here the method run, again the control jumps from the 29th line to the 17th line. So we got running safely here. Okay, after then the control again jumps back to the 30th line. Here we have the change gear. This is the method which is present inside the parent class. So the control jumps from the 30th line to the 8th line, which is present inside the parent class, and gear changed is printed here. I hope you all understood about the execution flow of this program. Now we have completed the abstract class. Okay. So what is abstract class? A class which is declared as abstract is known as abstract class. Abstract class can have constructors, abstract method and non-abstract method. Okay. What is the abstract method? It does not contain any implementation details. In the last session, we have discussed about the abstract class to achieve the abstraction. In this session, we will discuss about the interface. What is interface? An interface that is used to group related methods with empty bodies. So, what are the usage of interface? It is used to achieve abstraction and multiple inheritance in Java language. Okay, it cannot be instantiated just like the abstract class. So, what is the syntax? Interface is the keyword, and then the name of the interface, and inside the curly braces we declare the methods, okay, that abstract by default. Abstract method means it does not have any implementation details. The relationship between classes and interface. One class extends the another class, one interface extends the another interface, but the relationship between interface and the class, we have to use only the implements keyword. So if we want to inherit in between the classes, we have to use the extends keyword, and in between the interfaces also we have to use the extends keyword, but class with interface we have to use the implements keyword. So let's see this example. Here I have created the printable interface. Inside this printable interface I have declared the print method. So this is the abstract method. That means it does not have any implementation details. Okay, and I have created the class test interface 1, and implements keyword I have used because printable is not the class. This is the interface. So the test interface 1 inherits all the properties and behaviors from the printable interface. Okay, and inside the printable interface we have the print method. So this print method does not have any implementation details. Here inside the test interface 1 class only we have the implementation details for this print method. This is from the printable interface. Got it? And inside the test interface 1 I have the main method. So my file name must to be same as this class name only. And execution starts only from the main method. Okay, I have created the object obj for test interface 1 class. Okay, and here I call the print method using this obj. That is the name of the object. So what will happen? The control jumps from the 16th line to the 8th line. So hello will be printed on our console. Let me execute this one. Here we got the output hello. Okay, so what is interface? Interface that is used to group the related methods with empty bodies. I hope you all understood about what is interface. So we know already what is abstraction. So abstraction is the process of hiding the implementation details and showing only the functionality to the user. Okay, so here we can achieve the abstraction with the help of the interface, because inside the interface we have the abstract method only. Abstract method means it does not have any implementation details. Is it clear? Okay, here we have one more example. I have created two interfaces here, print and show. Inside the print interface I have the method declaration part, print, and inside the show interface I have the abstract method, that is it does not have any implementation details. And here I have created the test multiple inheritance. This is the name of the class, and I implement print and show interfaces. Okay, what structure is this? This is the multiple inheritance type. Okay, so single child, more than one parent. Okay, print is the parent, show is also the parent for this class. Okay, this is the class and print and show are the interfaces. That's why we have used the implements keyword instead of the extends keyword. Okay, and here we have the single child, more than one parent. So this type is the multiple inheritance type. Okay, so this child inherits all the properties from print as well as the show interfaces. Okay, here we have the implementation details for the print. This print is from the print interface. Okay, I simply print the hello on my console. Okay, and this is the show method. This is from the show interface. Here only we have the implementation details. Inside the show we didn't have any implementation details. Okay, and this show method is used to print the welcome on my console. Got it? And main. Inside this class only we have the main method. So my file name should be same as this class name only. Execution starts only from the main method. I have created the object for print interface and then the object for show interface. Okay, so interface also cannot be instantiated like the abstract class. That's why we have the child class name here. Okay, and here using this object I call the print method, and using this object I call the show method. Okay, this is the object of the print interface and object 1 is the object of the show interface. So what will happen after encounter this line? The control jumps from the 27th line to the 14th line. Here we have the hello. So this statement will be printed on my console, and again the control jumps back to the 28th line. Here we have the show method. So the control again jumps from the 28th line to the 18th line. Here we have the welcome statement. So this welcome will be printed on our console. Got it? And then again the control jumps back to the 29th line, the program is finished. Let me execute this one. Here, hello is the output for this statement, that is this one. Okay, and this is the output for the 28th statement, that is the welcome. We got welcome. Got it? So, in this example, we have implemented the multiple inheritance. Multiple inheritance means a single children, more than one parent. Children is the class, parents or the interface. Okay, that's why we have used the implements keyword in between the class and interface. Okay, I hope you all understood about how the interface is used to achieve the multiple inheritance in Java language. And we have another example. Here I have created the interface parent. Inside this parent interface, I have the abstract method, and I have created one more interface, a single INTE, and inside this interface I have disp child. This also does not have any implementation details. Okay, and here I have created the third interface, single INTE2. Okay, here I have used the extends keyword. Why? Because this is the interface, and this parent and single INTE also interfaces. That's why we have used the extends keyword. Okay, so if we want to inherit interface with interface, means we can use the extends keyword. Okay, and inside this single INTE2, I have the disp child2 method declaration part. Okay, this is the abstract method only. It does not have any implementation details here. And here I have created the class. Okay, single inter. This is the name of the class. Inside this class only I have the main method. So my file name must be same as this class name. Okay, and here I have used the implements keyword. Why? Because this is the class, but this is the interface only, isn't it? If we want to inherit class with interface, means we have to use the implements keyword, not extends keyword. Keep in mind. Okay, and inside this class, I have the implementation details for disp child and disp child2 and display parent. Okay, here inside the interface parent, I have only the abstract method. Single INTE, I have only the abstract method, and inside the single INTE2 also I have the abstract method. Okay, here only I have the implementation details of disp child2 and the display parent. So what is the role of this disp child? It is used to print I am a child1 interface. And what is the role of the disp child2 method? It is used to print I am a child2 interface on my console. And what is the role of the display parent? It is used to print I am a parent interface on my console. Okay, and here I have created the object for the class single inter. Okay, and I have used the object of this single inter class to call display parent, disp child and disp child2. After encounter this 34th statement, the control jumps from the 34th line to the 27th line, and this statement will be printed on my console. And then the control again jumps back to the 35th line. Here we have disp child. So the control again jumps from the 35th line to the 19th line. So I am a child1 interface will be printed on my console. Again the control jumps back to 36th line. Here we have the disp child2 call statement. So the control again jumps from 36th line to the 23rd line. I am a child2 interface will be printed on my console. Got it? I hope you all understood about the execution flow of this program. Let me execute this one. Okay. So execution starts only from the main method. This statement is the output for this 34th statement, and this is the output for 35th statement, and this is the output for the 36th statement. Okay, so we have completed the interface. So in Java, abstraction can be done using two concepts. First one is the abstract class and the second one is the interface. Okay. And interface is also used to achieve the multiple inheritance in Java language. Okay. In this session, let's discuss about the inner classes. What is inner class? A class that is created inside the another class. This type of structure is called the inner class. This is also known as the nested class. Okay. What are the advantages of inner class? Inner classes represent a particular type of relationship. That is, it can access all the members from outer class, including private. The second advantage is inner classes used to develop more readable and maintainable code because it logically group the classes and interfaces in one place only. Okay, and the third one is very important advantage, code optimization. It requires less code to write. Okay, these are all the advantages of inner classes. The next one, what are the types of inner classes? There are two major types of inner classes. The first one is non-static inner class. The second one is static inner class. Under non-static inner classes, we have again three classification. Member inner class, second one anonymous inner class, third one local inner class. Okay, now let's discuss the member inner class. So what are the rules we have to follow if we want to implement the member inner class in our project? Here, this is the example program. I have created the test member outer one. This is my class name. Okay, this is the outer class name. And inside this outer class, I have created the variable. Variable name is data. Its data type is integer. I have used the private as access specifier. Okay, so we know already private means we can use this variable inside this class alone. Okay, and inside this class I have created the one more class. What is it? Inner. This is the name of the inner class. Okay, so this inner class is placed inside this outer class. So what type is this? This is the member inner class. And one more condition, this class is created inside the outer class but outside of the method. Okay, so this type of structure is called the member inner class. Okay, class is created inside the outer class but outside of the method. So this type of structure is called the member inner class. This belongs to which category? Non-static inner class. Okay, and here I have created the MSG method. What is the role of this MSG? It is used to print the data variable value on my console. Okay, and inside this inner class I have the main method. Okay, and inside this test member outer one we have the inner, and inside the inner only we have the main method. So my file name must be the outer class name only, not the inner class name. Okay, because this inner class is placed inside the test member outer one class. So I have to give the file name as this class only, not this class. Okay, and here I have created the object for the outer class first. Okay, this is my outer class, and new keyword I have used to create the memory for this object during the execution of the program, and this is the default constructor. Okay, and I have created one more object for the inner class. Okay, this is the name of the inner class. How can I create? What syntax we have to follow? Here, this is my outer class name, and then dot operator and the name of the inner class, and followed by the object name. So this is the syntax. If you want to create the object for the inner class means you have to follow this rule. Okay, outer class name, dot operator, inner class name. And this is the name of the outer class object. Dot operator and then the new keyword and the inner class constructor. Got it? So we have to memorize the syntax. Okay, so the outer class name and then the inner class name. In between the outer class and the inner class name, we have to put the dot operator and then the name of the object for the inner class, and the right hand side we have to mention the object of the outer class and then dot operator and new keyword and then the inner class default constructor. Got it? And then here, what is it? This is the inner class object. So here this is the method which is present inside this inner class. Okay, so what will happen after encounter this line? The control jumps from the 14th line to the 6th line. Here this is the statement. So this statement will be executed. Again the control jumps back to the 15th line. The program is finished. I hope you all understood about the execution flow of this program. Okay, so what are the rules we have to follow if we want to implement the member inner class in our project means we have to create the class inside the another class. Okay, this is your outer class and this is your inner class, and this inner class must be placed outside of the method. Okay, this is the rule if we want to implement the member inner class. So this member inner class belongs to non-static inner class. Okay, and what is the syntax? If we want to create the object for the inner class means the outer class name, dot operator and inner class name and then the object name, and right hand side the object name of the outer class, dot operator, new keyword and then the inner class constructor. Okay, let me execute this one. So data is 30. Here data value is 30. So we got this result. Data is 30. In this session we will discuss anonymous inner class. What is anonymous inner class? A class that has no name. It should be used if we have to override a method of class. Anonymous inner class can be achieved in two ways. The first one, class. The second one, interface. Class may be abstract or concrete. Abstract class contains either abstract method or non-abstract method or both. Okay, so let's see this example. Here this is the concrete class. Concrete means this class contains the method that has the implementation details. Abstract class may contain abstract method or non-abstract method or abstract with non-abstract method. Okay, so here we have used the concrete class. So how can I implement the abstract inner class in my program? So this is my concrete class. Person 1 is the name of the class. Inside this person 1 I have the method. It has the implementation details, non-abstract method. So what is the role of this eat? It is used to print nice fruits on my console. Okay, and in this class I have created the main method. So my file name should be same as this class name only. Okay, and inside this method I have created the anonymous inner class. Okay, so what is this? This is the name of the class and this is the object for this class, and new keyword is used to create the memory for this object during the execution of the program, and this is the default constructor for this class. Okay, here there is no semicolon. Okay, and inside this curly braces we have the eat method implementation details. Okay, so what happened here? Here I didn't create any class. Okay, so what will happen? Here the compiler creates the class. So inside this class the inner class is created but that has no name, the compiler only decide the name of this class. Okay, so this structure is called the anonymous inner class, because here we have the class but there is no name. That's why we can call it as anonymous inner class. So we can use this object to call the method which is inside the anonymous class. Okay, so here this is the object name and this is the method which is present inside the anonymous inner class. Okay, so what happens? This method overrides the person1 method. Okay, this is our output. Nice fruits, super. Okay, so if we call this eat method means invokes the method which is inside the anonymous inner class only, not the method inside the person1. So this eat method overrides the method which is present inside the person1 class. Okay, so we got nice fruits, super. Okay, we didn't got the nice fruits. So this method overrides the method which is inside the person1 class. This method is from the anonymous inner class. Okay, I hope you all understood about the execution flow of this program. Okay, and we have one more example. So let's see this example. Here we have the abstract class. In this example, we have used the concrete class. But in this example, we have used the abstract class. So we know already the abstract class may contain both abstract and non-abstract methods, or abstract alone or non-abstract alone. Here I have created the person class. This class is the abstract class. Okay, inside this person class we have the abstract method. Abstract method is a class that does not contain any implementation details. So this is the abstract method. Okay, and here I have created the test anonymous inner class. Inside this class only we have the main method. So my file name should be this class name only. So this is my file name, test anonymous inner. And here I have created the object for person. Okay, and there is no semicolon here. You never forget it. And inside the curly braces we have the implementation details of the eat method. Okay, and here we have no class name. Okay, so what is it? This is the anonymous inner class. A class is here but there is no name. Okay, so that is created by the compiler. Okay, the compiler only decides the name of the inner class, and that's why we can call it as the anonymous inner class. This method overrides the method which is inside this person class. Okay, this is the rule. Okay, so here we have used the object and then dot operator eat method. So what happens after encounter this line, the control jumps from the 16th line to the 11th line only, not to the 3rd line. Here there is no implementation details because this is the abstract method. So this method only will be invoked. We will get nice fruits on our screen. Okay, let me execute this one. This is my output. Okay, so in the previous example we have seen the concrete class with the anonymous inner class. In this example we have seen the abstract class with anonymous inner class. Okay, let's see this example. We already discussed we can achieve the anonymous inner class in two ways. With the class, the second one is with interface. In this example we have used the interface. This is the name of the interface, eatable. So we know already the role of the interface. It is used to group the related method declarations. Okay, here we have only the declaration part of the method. That means it does not contain any implementation details. Okay, and here I have created the class test anonymous inner 1. Inside this class only I have the main method. So my file name should be same as this class name only. Okay. And here eTable is the name of the interface and this is the object. Here new keyword and eTable. New keyword is used to create the memory for this object during the execution of the program. There is no semicolon at the end of the statement. And here we have the curly braces. At the end of this curly brace only we have to put the semicolon. Okay. Here we didn't have any class name. That's why we can call it as anonymous inner class. Okay. Here inside the curly braces we have the implementation details of this each method. Okay. So what is the role of this each method? It is used to print nice fruits. Great. Okay. And here I have used the object of this eTable interface. Okay. After encounter this line, the control jumps from the 17th line to the 13th line. Okay. And this statement will be executed. Okay. Let me execute this one. Here nice fruits. Great. Okay. So this method overrides the method which is inside the eTable interface. So what is it? This is the anonymous inner class. Here there is no name. That's why we can call it as anonymous inner class. Okay. Now let's discuss about the local inner class. How can we create the local inner class? A class that is created inside the method is called the local inner class. Okay. Local inner class is created inside a block. Okay. So this type is called the local inner class. If we want to call the methods of local inner class, we have to instantiate the local inner class inside the method. I repeat it again. If we want to call the method of the local inner class, we have to instantiate the local inner class inside the method. Here I have created the local inner2 class and I have created the variable inside this local inner2 class. Its data type is integer. I have used the private access specifier. We know the role of the private access specifier. This data variable is accessible inside this particular local inner2 only. Okay. And I have initialized. The value of data is 30. Okay. And this is my user defined function display. And inside this display, I have created the local class. This is name of the class. So this local inner class is created inside this display method. So what is this? This is called the local inner class. Okay. Actually this class name is local. But what type is this? This is the local inner class. Why? Because this class is created inside the method of the outer class. Got it? Okay. And inside this local class, I have created the MSG method. What is the role of this method? It is used to print the value of the data variable on my console. Okay. And if I want to call this method, what I will do? I have to instantiate the local inner class inside the method. So here I have created the object of this local inner class. Okay. And here we know the role of the new keyword. New keyword is used to create the memory for this object during the execution of the program. And this is the local inner class default constructor. Okay. Now I want to call this method. So I can use this object to call this method. Okay. So we have to instantiate this local class inside this method. Okay. Now, after encounter this line, what will happen? The control jumps from the 18th line to the 10th line. Okay, and this statement will be printed on our console. The value of data is 30 will be printed. Okay, and here we have the main method. Inside this local inner 2, we have the main method. So my file name should be same as this class name. Okay, local inner 2 is my file name. And I have created the object for the local inner 2 class. This is the name of the outer class. Okay, and here new keyword is used, and this is the default constructor of this local inner 2. Now I call the display method. This method is placed inside this outer class. Okay, after encounter this line, the control jumps from the 23rd line to the display method. Okay, actually execution starts only from the main. Okay, so first this statement only will be invoked. Okay, and then inside this method only we have the local inner class. After encounter this line, the control jumps from the 18th line to the 12th line. Finally, this data will be printed on our console. I hope you all understood about the execution flow of this program. Let me execute this one. This is our output. Okay. So what happened here? So this is the main method. Execution starts only from this method. So here we have created the object for the outer class. Local inner 2 is my outer class name. And here this is the default constructor. And I have created the object obj. Now after encounter this line, the control jumps from the 23rd line to the display method which is present inside the local inner 2 class. Okay, so the control jumps from the 23rd line to the 4th line. So the control comes here. And here we have the local inner class. And inside the local inner class, I have the method MSG. Okay, and then here I have created the object for the local inner class. This is the name of the object of the local inner class. Okay, and this is the default constructor for the local inner class. And after encounter this line, the control jumps from the 18th line to the 12th line. So the value of data variable value is 30 is printed here. Is it clear? Okay. Now I uncomment this statement. Again I execute the same. Now our output is 500. Why? Because inside the display method we have this statement. Okay, so we got 500. Okay, if you not provide the data inside this display method means only the outside data is printed. Otherwise, the data which is present inside the display method only is printed. Okay, that's why we got this output. So we have completed all the non-static inner classes. So what are the types of the non-static inner classes? Member inner class, anonymous inner class, and finally local inner class. Member inner class is created inside the class but outside the method. Okay, inside the class but outside of the method. That is the member inner class. Anonymous inner class. A class is present inside the class but that does not have any name. And local inner class is created inside the class and inside the method. Okay, this type of class is called the local inner class. So we have completed the types of the non-static inner classes. In the previous sessions we have discussed about the non-static inner classes. Now let's discuss about the static inner class. What is static inner class? A static inner class is created inside the class. Okay, this structure is called the static inner class. It can be accessed by the outer class. it can access only the static data members and methods. It cannot access the non-static data members. Okay, see this example. Here I have created the class. Class name is test outer 1. And here I have created the variable. Variable name is data. Its data type is integer. Okay, here I have given the static keyword. If I use the static keyword with the variable means, okay, we cannot reinitialize this variable. Okay, and here I have created the inner class. Inner is the name of the class. Here I have used the static. So this structure is called the static inner class. Okay, and inside this inner class I have the method MSG. So what is the role of the MSG? It is used to print the data on my console. Okay, here this data is the static variable. Okay, that's why we can use inside this method which is present inside the static class. We now only discussed static class can be accessed to only the static data members. Okay, and here I have created the main method. Execution starts only from this line, and here I have created the obj object. How can I create? This is the outer class name, dot operator, and the static inner class name. Okay, followed by the name of the object. And right hand side new keyword and the outer class name, dot operator, inner class constructor. Here I want to access the method which is inside the inner class, that is the static inner class. What I will do, I can use this object to call that method. Okay, so obj.msg. After encounter this line, the control jumps from the 14th line to the 6th line. Okay, so here this statement will be printed on our console. That is 30 will be printed on my console. Let me execute this one. This is our output. Okay, I hope you all understood about what is static inner class and what is the execution flow of the static inner class and how can we create the object for the static inner class. Okay, and I have one more example. Here I have the test outer 2 class. I have the data variable, and inside this test outer 2 I have created the static inner class. Class name is the inner, and inside this inner I have the static method. Okay, actually in the previous example we have the same code, but here there is no static keyword. But in this example I have the static method. Okay, this is the difference between this example and the previous one. Okay, so what is the role of this one? It is used to print the data variable on my console. Okay, so this is the main method. Execution starts only from this line. Now I want to call this method. What I will do? First I have to create the object, but this MSG method is the static method. So there is no need to create object to call this method. Why? Because this is the static method. So no need to create any object. So we can use the outer class, dot operator, inner class name, and then dot operator, the name of the method. Okay, this is enough. Why? Because MSG is not a non-static method. This is the static method. Okay, so now after encounter this line, the control jumps from the 15th line to the 6th line. Okay, and the value of data will be printed on our console. Let me execute this one. Here this is our output. Okay, so if I remove this static keyword here means what will happen? Here we have the compile time error. Cannot make a static reference to the non-static field data. Okay, because this is the static inner class. So this static inner class can access only the static data members. If we use the non-static members, we got only the compile time error like this. Okay, again I write the same. The error is gone. Okay, let me execute. Here we got the output. So there are two types of inner classes. The first one is the non-static inner class. The second one is the static inner class. Okay, the non-static inner class is again classified into 3 types. First one is member inner class, second one is anonymous inner class, third one is local inner class. So we have completed the inner class concepts. Now let's discuss about the command line arguments. What is command line argument? Command line argument is an information that directly follows the program's name on the command line when it is executed. I repeat it again. Command line argument is an information that directly follows the program's name on the command line when it is executed. The command line arguments can be accessed in the Java program is very easy. They are stored as strings in the string array passed to the main method. Okay, let's see this example. Here I have created the class. Class name is command line EG. Inside this command line EG, I have created the main method. So my file name should be same as this class name. Okay, my file name is command line EG. And inside the main method, I have created 3 variables A, B and C. All are integer. Okay, and here I have implemented the typecasting because this argument's type is string. Okay, so what argument is this? This is the array argument. Okay, but I need the integer values. Okay, my task is adding 2 integer numbers. Okay, but this argument data type is string. So I have to convert this string into the integer value. That's why I have used this inbuilt method. Okay, integer.parseInt is used to convert the 0th index arguments to the integer. Okay, likewise, this inbuilt method is used to convert the first index value of arguments to integer. Okay, and here addition of a plus b will be stored inside the C variable. That value will be printed on our console. So, through command line arguments only, I will give the inputs. So, how can I give? Go to the run menu and run configurations. So, on the left side, we have the file names. So, here I choose this file, and on the right side, we have so many tabs. Here I choose this arguments. Inside this box, there is program arguments. I have to give the values. So, first value 13 for a variable. Give single space and then the second value 12. And click on this apply button and click on the run. So, this is our output. Okay. So, through command line arguments, I give the inputs. Okay. So, my first input is 13. That 13 is stored inside the arguments of 0th index. And my second input is 12. So, that value is stored inside the arguments of first index. Okay. So, these string values is converted to integer and that integer values is added, that value printed on our console. So, we got to 25. Okay. So, we can give the inputs through the command line arguments. Okay. So, the command line arguments must be the array string variable. I hope you all understood about the execution flow of this command line argument. We see one more example. Here, command line argument 2 is my class name. Inside this class, I have the main method. Here, I have implemented the for loop. Okay. So, I can give the inputs through the command line. Okay. So, what is my task? I want to print all the string inputs on my console. Okay. So, how can I execute this one? Go to the run menu, click on the run configurations and on the left side we choose the file name and click on the arguments tab on the right side, and we have to give the inputs: apple space banana space grapes space pineapple. Okay, enough. And then click on the apply and click on the run. We got the output: apple, banana, grapes, and finally pineapple. Okay, so our inputs are stored inside the string array arguments. Okay, so the 0th index holds the apple, first index holds the banana, second index holds the grapes, third index holds the pineapple. Here we have the for loop implementation. For the first iteration, the arguments of 0th value apple is displayed. Okay, and for the second iteration, I value is 1. So arguments of first value, that is banana, is printed here. Third iteration, the I value is 2. So arguments of second index value grapes is printed here. For the fourth iteration, I value is 3. So arguments of third index value pineapple is printed here. Okay, we know arguments dot length returns the length of the arguments. So arguments ARGS is the name of the string array. Okay, so arguments dot length returns 4. Okay, so how many times this loop is iterated? 4 times. Okay, for the first iteration 0 value, second iteration first, third iteration second, and fourth iteration third index values printed. Okay, I hope you all understood about the execution flow of this program. Okay, so we can give the inputs through the command line argument. So what is command line argument? Command line argument is an information that directly follows the program's name on the command line when it is executed. To access the command line arguments in the Java program is quite easy. Okay, and the command line arguments are stored as strings in the string array passed to the main. Okay, I hope you all understood about the command line argument. We have completed this session. If you have any doubts, drop the message on the comment section. If this video is useful to you, like and share. For more videos, subscribe my channel, hit the bell icon, then only you will get the notification for my new updates. Have a nice day. Thank you.